Welcome everybody, and in today's video we're going to look at how to build a major scale. We're going to give some more examples. And so hopefully by now you're a little bit of an expert in understanding this stuff. You understand that to build a major scale we have two distinct components. One, we need to write out the skeleton, and two, we need to adhere strictly to the intervals of whole, whole, half, whole step, whole step, whole step, half step. And if we do those two things, your scale will always build properly. Okay, so I wanted to give you a little bit of intuition about how we can build scales, and so we're going to look at some of the scales that I have listed out here below. So we're going to start with our A major scale, and so I'm going to go ahead and start just running through my rules. A, B, I'm writing out my skeleton, C, D, E, F, G, back to A. Once again, we did mention that our starting value and our ending value must match, so A all the way to A. Now let's go ahead and apply our whole steps and half steps. I'm going to do this rather quickly. So I'm going to look and I go, let's see, A to B is a whole step. B to C is not a whole step, but it needs to be. So we're going to call that C sharp. And then I look again from C sharp to D is a half step. That's good. D to E is a whole step. E to F is not a whole step, but it needs to be. So we're going to put a sharp on F. F sharp to G is not a whole step, but it needs to be, so we're going to put a sharp over here on G, so now it's G sharp, and then finally G sharp to A gives us another half step, gives us our final half step, and that is how we build the A major scale. Now let's take a look at the B major scale. You can actually do this whole step again. You could write out the skeleton, whole, half, whole, half. There's nothing wrong with that. But if I already know what the A major scale looks like, I'm going to cheat. And I'm going to go, well, I know that the distance from A to B is a whole step up. So we're talking about a vector here. We're talking about something that has a distance and a direction. We're talking about the distance from A to B is going up, and it's going up by a whole step. It's a very distinct value. So B has to be a whole step higher than A. Then I want to think to myself, what is a whole step higher than B? And that would just simply be C sharp. All right. And let's keep going on with that. And what is a whole step higher than C sharp? It would be D sharp. What is a whole step higher than D? And that would be an E. What is a whole step higher than E? That would be F sharp. And what is a whole step higher than F sharp? And that's going to be G sharp. What is a whole step higher than G sharp? And that would be A sharp. And obviously our last one must be AB. And so you could see that if I already know a scale, if I know a scale or two, I'm kind of in a good, unique place. If I know what A major looks like, and I know the distance from A to B is a whole step, then this distance has to be a whole step. This distance is a whole step, whole step, whole step, whole step, whole step, whole step, whole step. And if you wanted to verify for yourself that this B major scale actually comes out correctly, you could. B to C sharp is a whole step. C sharp to D sharp is a whole step. D sharp to E is a half step. So I've got whole, half. E to F sharp is a whole step. F sharp to G sharp is a whole step. G sharp to A sharp is a whole step. And A sharp to B is a half step. So now I've got the scale whole, half, whole, half. And again, all of the values are going to be a whole step when compared to the A major scale. These are all going to be a whole step higher. And that should make logical sense to you because A to B is up by a whole step. Well, what if I wanted to do something like build the B flat major scale? At this point, I have essentially maybe, three ways I could do it, right? I could certainly use our earlier method, this guy. I could go, well, let me write out the skeleton and do my whole, half, whole, half. I could also consider, well, wait a minute, isn't B flat a half step higher than A? And the answer is yes, I could do something like that. Or I could also consider, well, B flat is a half step lower than B. And since we already did the up method, going from A up to B, and kind of considering that perspective, let's consider going what it would look like going down. All right, so we know that it's going to be B flat. In fact, I'll go ahead and do us the favor and just write out B flat over here. And let's go ahead and just kind of write this through. And I just maybe want to consider that B flat is a that B flat is a half step lower than a B. So what is a half step lower than C sharp? And if you said C, then you're correct. And what is a half step lower than D sharp? And that would be D. What is a half step lower than E? And that would be E flat. What is a half step lower than F sharp? That would be F. What is a half step lower than G sharp? That would be G. What is a half step lower than A sharp? And that would be an A. And so you could see there's various ways to build these scales. One is by using our very distinct set of rules. Those are our tried and true rules, and they're never going to fail us. But the other method is, well, what if I already know a scale? If I already have something memorized by heart? And I can think of one, for example, that is very easy to memorize, one that we've talked about before that should be sort of on our to-do list to memorize, and that would be the C major scale. C, D, E, F, G, A, B, C. And if I knew that scale, which is not very hard to memorize, as you can see it's all naturals, well then shouldn't I be able to get all the other scales that are relatively close to that for free? For example, what about the B major scale? Well, that's a half step. What about, let's say, the B flat major scale? That's just a whole step down. Or what if I had D flat? Or possibly D. These are scales that are very close. These are just, this distance here would be a half step up. So this is going up. And then this is going down. And this is a half step here. And here to here is a whole step. This is a half step down. And then this distance would be a whole step down. And so just by knowing my C major scale and understanding the notes and understanding sharps and flats, I should be able to build, goodness, I've got 5 scales here. 5 major scales. And let's think about that number for a moment. How many scales do we have? Well, we have a total of 12 major scales. So we have a total of 12 major scales. 12 major scales. Right? We have one for each of the notes in music. So we have one for A sharp, B, C, C sharp, D, D sharp, so on and so forth. So we essentially have 12 major scales. Just think of it as 12 scales. And then what we're going to do is think that, well, if I have only 12 scales, and if I knew this method over here that we just talked about, this thing about if I understood C and then going up and C and going down, that provides me with 5 out of the 12. And so now I have 5 out of the 12, which is pretty close to 50%. So this is an easy way to knock out roughly 45% or so of the major scales just by knowing this neat little trick. On future videos, we're going to continue to analyze scales and look at them and get a better understanding of major scales in music.